Hi, welcome to Building Codes. I'm Becky Roska with State of Oregon Building Codes Division. The division provides a wide range of services to the public and to Oregon's construction industry, including code development, inspection, plan review, licensing, permit services, and building code training. This training video has been prepared by our Training and Outreach Program. Dana Fisher, our Training Program Support Coordinator, has more.
Hello, I'm Dana Fisher, Building Code Division's Training Program Support Coordinator. Welcome to the Code Update Training for the 2022 Oregon Mechanical Specialty Code. In this video, the Oregon's Building Codes Division will cover significant changes to the latest iteration of the Oregon Mechanical Specialty Code, the OMSC. All BCD inspector certification holders are required to complete code change classes provided by the division to maintain their active certification. For this training course, objective is to identify the significant technical changes for the design and installation of mechanical systems construction requirements resulting from the adoption of the 2022 version of the OMSC. As always, we welcome any and all inquiries regarding technical content. At the end of this training video, division contact information will be provided where you may submit your inquiries. The division website page includes the updated contact information for the presenters in this training. The division webpage also includes a codebook availability information for the 2022 OMSC and information of codebook vendors as a courtesy to those who are looking to purchase a copy of the code. In early 2023, the division anticipates holding in-person question and answer sessions, depending on customer demand and staff availability. Please note that the structural and commercial code changes are not part of this training. In a separate training, the significant changes from the 2019 Oregon Structural Specialty Code to the new 2022 Oregon Structural Specialty Code, OSSC, will be discussed. This and other informational resources and updates are available through our website. Now, let's turn our attention to the OMSC Code Update Training. We appreciate you turning in to this presentation and look forward to working through the updates with you. Model code revisions for the 2021 IMC are shown as red underlined for additions in the model code and red strike through for Oregon model code deletions. Oregon amendments are shown as blue underlined for additions and blue strike through for existing amendment deletions. The presenter for this training is Mark Heiser. Mark joined the division in 2010 and is BCD's Mechanical and Engineer Code Specialist. He has over 25 years of mechanical design experience. Mark has designed residential and commercial projects both in the U.S. and abroad. His engineering work includes large capital projects for the State Department as a project manager and a lead mechanical designer for new U.S. Embassy construction projects. Today, Mark also participates in the development of national mechanical and energy code standards. This includes his participation with ICC and ASHRAE. He also keeps a pulse on national rulemaking organizations, such as the U.S. Department of Energy. Mark, along with Kelly Thomas from our policy staff, cover all things on energy code and are both experts on Oregon's energy code provisions and upcoming changes to meet statewide energy conservation goals. As a reminder, our team is a technical resource for our local government partners and other customers. We are always happy to assist and always appreciate hearing from you.
Hello, I'm Mark Heiser, Mechanical and Energy Engineer for the division. I'll be presenting the significant changes found in the 2022 Oregon Mechanical Specialty Code. As noted for the 2022 Oregon Structural Specialty Code change classes, this presentation is not intended to include every revision. There will be minor updates and editorial corrections that will not be covered today. The 2022 Oregon Mechanical Specialty Code is a combination of the 2021 International Mechanical Code and the 2019 Oregon Mechanical Specialty Code, which was based upon the 2018 IMC. For 2022, the Chapter 1 administrative provisions have been updated to provide better alignment with the structural code. The 2022 OSSC has been revised this year to cleanly delineate the building department authority, along with general language updates to make enforcement easier. Chapter 1 of the OMSC has been updated to reflect the structural code revisions. In addition, some editorial revisions have been made to better align numbering and naming conventions between the OMSC and the OSSC. There isn't an exact duplication, but you will find better alignment when moving between the administrative provisions of the two codes. The first significant change we'll cover today is an update to Oregon amendments to Section 307.2.1. Previous Oregon amendments were restrictive and did not provide flexibility for condensate drain discharge locations. New language has been added that will now allow discharge to other approved locations. A new subsection has been added to Section 307.2.1. The language clarifies standard practices used for connection of HVAC condensate drain discharge to a plumbing system. Indirect drain connection methods, which separate the HVAC work from the plumbing code work, are described. Note the condensate discharge that drains to a plumbing system within the building must be located within the same occupancy, tenant space, or dwelling unit. For Section 401.2, outdoor air ventilation for buildings can be met using either natural means using Chapter 12 of the Building Code or by mechanical means using Section 403 of the Oregon Mechanical Specialty Code. For dwelling units, the 2018 IMC required mechanical ventilation if the building was tested for air leakage and if that air leakage result was less than 5 air changes per hour. This was already confusing language as testing was optional for buildings under the 2019 Energy Code. And for the 2019 OMSC, the reference to Section R402.4.1.2 was removed, which is from the residential energy provisions of the International Energy Conservation Code. So the model code application would have been only for low-rise residential buildings 3 stories and less. Moving on to the blue language shown in double strike through, the 2021 IMC language was modified to require mechanical ventilation for dwelling units when any energy code was used. Both of these sections of language were struck by the Code Committee and the Mechanical Board pending review of all implications, including low-rise versus high-rise dwelling unit ventilation, as well as energy code impacts. A code revision may be issued at a future date, but for now, a dwelling unit can continue to use either natural ventilation or mechanical ventilation methods. Section 401.4 sets limitations on the distance between outdoor air intake openings and other sources, such as an exhaust flow or, say, a loading dock. Part 3 requires an outdoor intake, if not less than 3 feet lower than an exhaust outlet, must have at least 10 feet of horizontal separation. New language was added that if a dwelling unit uses a factory-built combination inlet-outlet, there is no requirement for additional separation. Note that the board approved the removal of requiring an approved factory-built outlet. Possible uses you might see would be for an energy recovery unit, but as a reminder, the exhaust can only be living space exhaust, not something like dryer or range hood exhaust. Table 403.3.1.1 sets the ventilation rates for different space types. Some space types are required to have exhaust, and then are prohibited from recirculating any air from that space. These space types will have footnote G in the ventilation table. Footnote G describes the applications. The 2019 OMSC had an exception for recirculation of up to 10% of the airstream. This note was unclear, as it was intended to address energy recovery units with a heat wheel. These type ARVs will always recirculate some of the exhaust airstream back to the supply airstream. For the new code, this 10% allowance was clarified. It only applies to heat wheel type energy recovery ventilation systems. The model code included a limitation to occupancies other than science laboratories. This language was problematic for the board since science laboratory wouldn't include all laboratories. Since other exhaust streams may not be acceptable for recirculation, the exception is modified so that the allowance is for environmental exhaust only. This would exclude exhaust from hazardous exhaust systems or other unacceptable exhaust air streams. Demand control ventilation systems allow for the outdoor air ventilation rate to be reduced when a space is unoccupied or at a low occupancy. The controls can be based on occupancy sensors, carbon dioxide sensors, or other means. Using Table 403.3.1.1, airflow to each space may be based on both a flow rate per person in the space as well as a flow rate per floor area, effectively a CFM of outdoor air per occupied square foot. New language was added to the IMC that has allowed the use of demand controls to reduce the per person airflow rate. However, the demand control airflow calculations are required to maintain the per floor area airflow rate. So the space outdoor air rate does not go to zero in the calculations when the table has a per floor area requirement. As a side note, there are still engineering methods where all ventilation airflow can be stopped to an unoccupied space, including adjustments for average ventilation over time. The 2020 OMSC clarifies a question that we've been asked a few times here at Building Codes, that domestic residential kitchen exhaust systems can't be mixed with other exhaust systems. Prior to this update, getting to the cited answer required going to several other code sections. Now it is clearly identified at the beginning of Chapter 5 that residential range exhausts can't be mixed with other exhaust systems. And the model code has also clarified a more obvious issue, that hazardous exhaust systems need to be independent as well. Finally, some additional clarification is added. Sections 506 through 509 apply to commercial kitchen operations, not a domestic kitchen exhaust system. Oregon has had requirements for exhaust at manicure and pedicure stations for over 10 years. Model code now requires that these exhaust systems be operational during operating hours. So the fans should either be on a time clock, interlocked with an occupancy sensor, or interlocked with the main HVAC system. You may see other options for controls in the field. Dryer termination locations are now limited to no less than 3 feet from any building opening if the manufacturer's installation instructions don't already specify a greater distance. This includes building ventilation openings like soffit vents. You don't want wet air from the dryer vent to re-enter the building through a soffit vent, whose sole purpose is to introduce dry air into the building cavity. Section 504.4.1 has been modified to clarify that a standard booster fan cannot be used in a dryer system. This is not preventing the continued use of dryer duct power ventilators as allowed under Section 504.5. These fans are specifically designed and listed for use in a dryer system. These fans come with specific installation requirements, including the placement of the fan and pressure switches used to start the fans. Type 1 grease exhaust duct runs are required to be sloped at 2%, either toward the hood or a grease reservoir. A new exception has been added for factory-built grease ducts, installed per the manufacturer's installation instructions. The product's installation instructions are, of course, tied to the specific testing used to attain the ductwork's listing. So the minimum slope allowed for factory-built ducts could be either greater or less than 2%. Many restaurants have added smoker ovens, and how to treat these has been a recurring question for the division. A new exception to Section 507.1 allows smoker ovens with integral exhaust to not require a hood, but only when the oven's listing allows for installation without a Type 1 hood. Before this new exception, a smoker oven would be considered as producing grease and smoke, which requires a Type 1 hood. Yet these normally operate at low temperatures unlikely to approach the ignition point for the grease, and the cooking is fully contained within a metal casing, basically an oven. Further muddying of the review would be the burning of smoker chips, which could be considered an open flame combustion of solid fuel at any time, meeting the definition of an extra heavy-duty appliance. With the new exception, a hood is not required for a smoker oven meeting this exception. Energy recovery ventilator systems can now accept airflow from Type 2 kitchen exhaust systems. Type 2 systems are used for exhaust streams with only heat and humidity. Type 2 examples might include exhaust from a commercial dishwasher. Unlike Type 1 airstreams, clogging of the heat recovery surfaces are not an issue with Type 2 exhaust. Under the 2019 OMSC, plastic pipe or other assemblies that did not meet the 2550 flame and smoke spread index could be covered with any material that did meet the 2550 requirement. So covering plastic pipe with pipe insulation that met the 2550 rating could allow the plastic pipe to be installed in a plenum. For 2022, when pipe insulation is used to cover pipe in a plenum, the insulation must comply as a tested assembly of both the plastic pipe and the insulation to maintain the 2550 flame and smoke spread index. Through the years, the requirement for fire dampers and metal ducts penetrating a 1-hour fire barrier has seen several variations. Currently, Exception 3 to Section 607.5.2 allows a minimum 26 gauge metal duct to penetrate the barrier wall without a fire damper where the metal duct is continuous from the air handler to the air outlet. This has led to some confusion since most systems will have a flexible connection at the air handler and are likely to have flexible duct running for some distance to the diffusers, at least somewhere in the duct system. The modification for the 2022 OMSC now allows flex ducts and connectors where the supply or return system is fully ducted. Then, non-metal duct can be used at the following locations: at connectors to air handlers located in the mechanical room, and as air connector runouts per Section 603.6.2 from the metal duct to diffusers in the same room. So, no crossing walls with flex duct. And Section 603.6.2 limits the flexible connector length to no more than 14 feet. Subducting of exhaust has been common for R occupancies when using Section 607.5.5, exception number 2. A common example is where bathroom exhaust in an apartment goes into a shaft. The penetration doesn't need a fire smoke damper when a steel subduct extends 22 inches vertically into the shaft ductwork. For this to apply, the exhaust fan must run continuously and maintain upward airflow. Exception 2 is limited to Group B and R occupancies. A new code modification to Exception 1 now allows subducting for other occupancies. Further new language is found in Section 607.5.5.1. This is intended to clarify subduct system operation. A subducted system can't have any fire or smoke dampers anywhere in the system that might prevent continuous upward airflow past a subduct. If the damper closes and the required continuous airflow past any subduct were to stop, then these subducts would no longer be effective. Smoke or fire could enter spaces without fire smoke damper protections. So, placement of fire or smoke dampers is prohibited where their closure might interfere with the intended operation of a subduct system. Section 403.3.1.5 balancing has been relocated to Chapter 6. This is a heads up to let you know that when you see new Section 608.1, that this is not a new requirement, just a relocation to its more appropriate setting in Chapter 6. Chapter 6 sets duct construction requirements, so the installation of balancing dampers could be overlooked if located in Chapter 4, which is focused on ventilation design. New Section 801.21 requires that new oil-fired appliances be provided with a blocked vent safety switch. In the event of an obstruction or other hazard preventing proper relief of products of combustion, the burner will cease operation. And when the safety switch is triggered, the system must then be manually reset. The code has added a new Section 905 to recognize wood-fired hydronic heaters. These units now have an EPA combustion certification, just like residential wood stoves. These units are open systems and are not pressurized. Your customer may sometimes call it a wood boiler or wood furnace, but it usually will not fall under the boiler program. When outdoors, you will be addressing the piping to and from the building. New Section 930 has been added for unvented, alcohol fuel burning decorative appliances. These have grown in popularity, and a new UL listing 1730 was developed for these units. Where the code was previously silent, there is now a section for their use. No more need to seek a local alternate or special approval for their use. As a side note, the division has received prior inquiries about alcohol cooking and heating devices. Some were cooktops intended for use aboard boats. The new UL 1730 does not cover these appliances, so any request to use these appliances would remain a local alternate method request. Chapter 11 Refrigeration has had a few reorganizational changes. The biggest revision is relative to ammonia refrigeration systems. The code now has fewer construction provisions relative to ammonia systems. Instead, the code is referencing the IIAR standards where appropriate. This avoids duplication of language or conflicts between the standard and the code itself. This is similar to ASHRAE refrigeration standard references, or, as another example, references to NFPA 99 for the design and installation of medical gas systems. These systems are so specialized that the national standard is relied upon in the code. Next, Section 1107 for refrigeration piping has been reorganized for clarity. The section has been split into sections 1107 through 1110. Finally, machine room means of egress language has been removed. As a rule, requirements for egress are found in the building code where it belongs. The mechanical code will not inadvertently set building construction standards in conflict with the building code. And as a reminder, the OMSC will apply to machine rooms over 1,000 square feet. Moving on to the Appendix C Fuel Gas provisions. There has been a revision to the condensate drain provisions from combustion appliances. Where a secondary drain is concealed, the outlet of the secondary drain must be clearly marked with an embossed or engraved tag, or in an otherwise approved manner. It is important to know when a secondary discharge is active. This means that the primary drain is blocked and that maintenance is necessary. Blockage of the primary drain on a combustion system can present more than just possible damage to the structure. There could be problems in the combustion chamber that might present hazards to the building occupants. So, if the secondary drain is not visible from the appliance all the way to the discharge location, the secondary drain outlet needs to be clearly labeled. The manufacturer's installation instructions for some types of CSST flexible gas pipe require extra bonding of the material beyond the minimum required in the electrical code. Section 310.1 and new Section 310.1.1 clarify the intent of meeting the manufacturer's installation instructions when the material needs extra bonding. This is usually requiring a larger wire size for the bonding. And as a reminder that the work, materials, and methods have to be per the electrical code. Bonding is electrical work. There were a few minor gas code revisions and editorial updates that you should be made aware of. The first revision covers press connect joint systems where special pipe connector fittings are compressed onto gas pipe using specialized tools. The use of these systems was recently added to the model code, and for this year, the code recognizes that there are now press connect systems that can be used for systems operating over 5 pounds per square inch. It is not often that you will see systems operating over 5 psi, but this method is available in lieu of welding or other methods in the current code. Next, the thread joint compound section has been renamed as threaded joint sealing. In addition, language was added to better address the materials used for sealing a threaded joint. Finally, under Section C 409.7, an old Oregon-specific amendment has been deleted. The deleted amendment had allowed a shutoff valve at a gas fireplace to not be independently supported if installed per the manufacturer's installation instructions. This deviation from model code was seen as no longer pertinent. When reusing an existing chimney, prior code had exceptions to allow for the continued use of an unlined chimney when replacing an appliance. This exception implied the system would be inspected in order to allow continued use of the unlined chimney. This allowance has been removed from the code for commercial applications. Replacement of appliances can no longer use an unlined chimney. To add perspective for this revision, an unlined masonry chimney is likely to be over 40 years old. Other gas code revisions include two minor changes to venting. Section C 503.8 adds new language and a figure C 503.8 for through-the-wall vent terminal clearances. The new language and diagram show the required clearances between a sidewall vent and openings into a building. The one exception is that this does not apply to the minimum distance between the vent outlet and the combustion air intake for direct vent appliances. The next revision clarifies the junction fittings for appliance vent connectors under new section C 503.10.7. The fittings must either be a Y or a T fitting. So when joining a vent connector section to other sections of the system, cutting a hole in the trunk line, then inserting the connector and patching is not allowed. This connection must be a fitting. The last revision to the gas appendix we'd like to cover is relative to section C 618.6, warm air furnaces. The warm air furnace section now clearly prohibits return air from being taken from a mechanical room where the furnace is located. The negative pressure draw from an open return in the mechanical room could place the room itself under a negative pressure. This could cause a backdraft of the furnace combustion and venting system.
Congratulations! This completes the 2022 OMSC Code Update Training. Thank you for watching this presentation. We hope it was informative and enjoyable, and we appreciate you making it all the way through. Providing useful information to all of you in an efficient manner is important to our team. If you have any questions or comments, please contact the Training and Outreach Program.